Hello everyone, welcome back to my TSS series, and in today's video we are going to talk about one of the most elegant and commonly used problem solving patterns, that is two pointers technique. We will understand what it is, why we use it, the intuition behind it, and solve one example step by step from brute force to optimized big of n solution. This concept is very important for interviews and shows up in many problems like Pearson, palindrome, and removing duplicates. So let's begin. So what is two-pointer technique? The two-pointer technique is a pattern where we use two variables or pointers to traverse an array or a string. Let me draw array first. Okay. Suppose this is our array on. So instead of looping all the elements multiple times, we use two pointers or two variables based on certain conditions. So let's say this is one pointer and we have another pointer here, this one. So depends upon the problem, we use these pointers. So we will move these pointers towards each other in case of problems like Pearson palindromes, or we will have we can have two pointers together and they will move one after each other. For example, this will move faster, the second will move move smaller in case of duplicates or removing zeros and all that. So it depends upon the problem, we can move this arrow and it will give us an efficient solution which will be much better than the brute force. So let's understand with the help of an example so that you can better know why we are using. Let's understand this with the help of an example. Okay. So let's suppose we have an array which is equals having values 1, 2. So let's have an array which is sorted. This is very important to understand. Sorted array having values 1, 2, 3, 4, 7, 10, 11, 15. And we have to find a pair. We have to find a pair, the sum of whose is 15. So what will be the approach? First approach will be to get all the pairs and their sum. For example, we can have 1 plus 2, which gives us 3, but our target is 15, so this pair will not work. Then we can have 1 plus 3, which give us 4 again, which is less than 15. Similarly, we can have another pair, 1 plus 4, which gives us 5. So similarly, we can have n number of pairs, and we can also have 11 plus 15, which give us 26, which is greater than our target. So if we follow this approach will definitely work, but it will check every combinations like 1 2 1 4 1 7 1 10 1 11 1 15 2 3 2 4 and so on. So there will be around 21 pairs for these numbers. So this approach will definitely find a pair which will have a target 15. But do you think this is an efficient way of finding? Because the time complexity will be around big of n square, because we are finding all the pairs. So there will be very high time complexity. And if there are suppose 10 raised to the power of 5 elements, around 10,000 1 lakh elements, then our that's operation will be around double of that. For example, if an array has around 1 lakh of elements, then 2 lakhs combinations will be there, which will be very inefficient way of finding or approaching a solution. So how can we better it? What is the better approach? We have to find out the intuition first. Okay, so the intuition behind two pointers. Let me draw the array again, just I can copy it from here. Okay, so I can just copy. So as we know, we use two pointers and the array is sorted. Okay, so the array is sorted, and in the way that at the first we have the smallest element and at the end we have the largest element. Okay, so let's pick two pointers. Let me change the color. One pointing to this and another pointing to 50. Okay, now if we pick two numbers and their sum is too small, it means suppose the sum is 16. Here the sum is 1 plus 15, which is equals to 60. So if which is greater than our target, so what we have to do, we have, if we just increase this the smallest pointer, then our sum will increase. So we have to reduce this to its previous one. Okay, so let's remove it and we can draw, we can point to 11 now. Now what the sum is? Now our next value is 11, 1 plus 11, which is equals to 12. Now this is smaller than the target, so our the next we should do is increase the smallest one and move it to 2. Okay, move it to 2. Now the sum will be 2 plus 11, that is equals to 13, again which is smaller than our target. So we will erase it, we will move the left pointer to the next element. So what is the value now? Value is 3 plus 11, which is equals to 14, still smaller than our target. Then we have to erase it again and move our pointer to the next element, that is 4. Now let's check what is 4 plus 11 is equals to 15. This is our target value. Let's see, in the very small comparisons we get the value, because the intuition is the array is sorted, the smallest is on the left and the biggest is on the right. So if we just have to remember one thing, that if sum is less than target, then left plus plus, that we have to move the left pointer. If sum is greater than target, then right minus minus, we have to move the right towards the left. And if sum is equals to target, then it's found. So this is the mantra, this is the goal that we have tried to achieve in two-pointer algorithms. Just move the pointers efficiently, don't need to check all the combinations. Okay. So our next topic is, what are the common patterns that we can solve using two pointers. So the two pointers technique isn't just for this one problem, it's a pattern used in many others problems to solve. For example, if we follow opposite direction movement, then what problems we can solve? We can solve Pearson, palindrome. Okay, so what is the strategy for this type of problems? Strategy is to move inwards. Okay, next is, if we move the pointers in same direction, then what problems we can solve it is remove duplicates, removing zeros, and the movement of the pointers is one reads and one writes. Okay, and there is another type of problems that we face in using for two pointers, that is fast and slow. And what problems we are solving using this? Detecting cycles. The pointers move at different speeds. Okay, so we will cover all those patterns, all those problems in this coming videos. So don't worry, you will be very much sure of using two pointers. I will also give you a PDF for all these problems. Okay, now at the end I will give you some interview tips and summary. Okay, so before we wrap up, here are the few interview tips that you should keep in mind. First, check if array is shorted. Okay, if your array is shorted, then only we can use two pointers algorithms. Okay, second is, clearly define the pointer movement, that is whether to move inwards in case of pairs, move in the same directions and same speed in case of duplicates, or same direction in different speeds in case of finding cycles. Third is, understand overlapping conditions. This one is when to stop the pointers checking. As I've told you, as shown in the example, that whenever the sum is equals to the target, then we have to stop checking. Or whenever the left is greater than the right, in case of Pearson, we have to stop. So we have to understand and clearly define what are the overlapping conditions are. Okay, so this is a few tips that you should remember when you are applying two pointers algorithms. And just remember, brute force means checking each and every pair. Two pointers move smartly. Okay, so that's it for this video. If you found it helpful, please like this video and subscribe to this channel for more tech stuff. Okay.